Quality management is a module to understand the quality concepts, world-class quality and quality culture. By learning quality management you will be able to implement quality principles in your organization, to make it quality organization. This quality management course provides beginners with an introduction of quality management. This course will tells you about quality standard, quality concept, quality tools etc. Quality management is the process of overseeing business activities and people to achieve and maintain a desired level of excellence. Some glimpse of quality management course you will see in next slides. Quality management has four main components which include quality planning, quality assurance, quality control and quality improvement. Quality planning. Quality planning is the first of four steps. In this step, someone must identify the requirements and important procedure needs to be recognized as part of the planning. The process of identifying the quality standards relevant to the project and deciding how to meet them. Quality assurance. The systematic or planned actions necessary to offer sufficient reliability so that a particular service or product will meet the specified requirements. Quality assurance is a complete system to assure quality of the products produced by the organization. It is not only a process, but a complete system which also includes controls. It is process-oriented and ensures that right things are being done in a right way. It is a way of management. It is an effective tool in the hands of the management to mitigate risk. Quality control. Quality control is a process which measures and determines the quality level of products. It is the activities or techniques used to maintain the product quality. It is the way of ensuring that the results of the manufacturing process are the same as was expected. It emphasizes testing of products to uncover defects and reporting to production management to make the decision to allow or deny product release. Quality improvement. The fundamental concept underlying quality improvement is that a system left unchanged can only be expected to continue producing the same results. To achieve better performance, it is necessary to change the system in ways that enable it to produce the improved result. Quality improvement is a systematic, formal approach to the analysis of practice performance and efforts for the improvement of the performance. Quality management principles are a set of fundamental beliefs, norms, rules and values that are accepted as true and can be used as a basis for quality management. These principles are: 1. Customer focus. The primary focus of quality management is to meet customer requirements and to strive to exceed customer expectations. 2. Leadership. Leaders at all levels establish unity of purpose and direction and create conditions in which people are engaged in achieving the quality objectives of the organization. 3. Engagement of people. It is essential for the organization that all people are competent, empowered and engaged in delivering value. Competent, empowered and engaged people throughout the organization enhance its capability to create value. 4. Process approach. Consistent and predictable results are achieved more effectively and efficiently, when activities are understood and managed as interrelated processes that function as a coherent system. 5. Improvement. Successful organizations have an ongoing focus on improvement. Improvement is essential for an organization to maintain current levels of performance, to react to changes in its internal and external conditions and to create new opportunities. 6. Evidence-based decision-making. Decisions based on the analysis and evaluation of data and information are more likely to produce desired results. 7. Relationship management. For sustained success, organizations manage their relationships with interested parties, such as suppliers. ISO 9001 states the requirements for your quality management system, that is QMS. There are 10 clauses in ISO 9001, with additional sub-clauses related to the plan, do, check, act system. However, only clauses 4 to 10 contain requirements that are auditable. Clause 1, Scope. This clause defines the scope of the 9001/2015 standard. In summary, the scope includes specifying requirements for a QMS of any organization. Clause 2, Normative References. The supporting standard referenced in ISO 9001/2015 and is indispensable for its application is ISO 9000/2015, which covers terminology and fundamentals. This and other supporting standards make up the 9000 series. Clause 3, Terms and Definitions. Terminology used throughout this standard comes directly from ISO 9000/2015, Quality Management Systems, Fundamentals and Vocabulary. Clause 4, Context of the organization. When you are implementing your quality management system or QMS, the first step for ISO 9001 requirements is to thoughtfully align your business objectives and intent with the QMS. Determine external and internal issues, the needs and expectations of interested parties, quality management system scope and its processes. Clause 5, Leadership. Clause 5 of the ISO 9001/2015 requirements covers leadership responsibility. Top management must demonstrate leadership and commitment, establish and communicate a quality policy, and ensure responsibilities and authorities are assigned, communicated and understood. Clause 6, Planning. Clause 6 of the ISO 9001/2015 requirements covers organizational quality management system planning to address organizational risks, opportunities, changes and quality objectives. Clause 7, Support. Clause 7 of the ISO 9001/2015 requirements covers the resources needed for the QMS. This covers providing resources, ensures employees are competent and aware, and includes documented information to support your quality management system. Clause 8, Operation. Clause 8 covers the plan and control processes needed to meet the requirements for products and services, that is design and development, external providers, production and service provision, release of products and services, non-conforming outputs. Clause 9, Performance Evaluation. ISO 9001 requires your organization's QMS to monitor, measure, analyze, and evaluate your quality management system. Clause 10, Improvement. ISO 9001/2015 requirements for Clause 10 are based around continual improvement. Select opportunities for improvement, take action against non-conformities, implement corrective actions as necessary, and continually improve your quality management system. Quality management training helps organizations achieve greater consistency of production processes. The training platforms are designed to help in increasing process efficiency, reducing wastage, and improving the use of time and resources. Training a workforce to the highest standards will improve product quality, decrease employee anxiety, increase performance, and ultimately give focus to the customer. The QMS documentation can consist of different types of documents. Usually, it includes documents such as the quality policy, quality manual, procedures, work instructions, quality plans, and records. A well-designed documented system has many benefits. It ensures quality standards are routinely met, minimizes the potential for error, reduces downtime, when deviations occur due to being able to quickly access relevant data, and allows for easy monitoring of the processes, such that process outputs are analyzed and appropriate adjustments are made. Statistical quality control. The use of statistical methods in the monitoring and maintaining of the quality of products and services. One method, referred to as acceptance sampling, can be used when a decision must be made to accept or reject a group of parts or items based on the quality found in a sample. A second method, referred to as statistical process control, uses graphical displays known as control charts, to determine whether a process should be continued, or should be adjusted to achieve the desired quality. Statistical process control. SPC uses sampling and statistical methods to monitor the quality of an ongoing process such as a production operation. A graphical display referred to as a control chart provides a basis for deciding whether the variation in the output of a process is due to common causes or randomly occurring variations or due to out-of-the-ordinary assignable causes. Whenever assignable causes are identified, a decision can be made to adjust the process in order to bring the output back to acceptable quality levels. Accepting sampling. The design of an acceptance sampling plan consists of determining a sample size N and an acceptance criterion C, where C is the maximum number of defective items that can be found in the sample and the lot still be accepted. The key to understanding both the producer's risk and the consumer's risk is to assume that a lot has some known percentage of defective items and compute the probability of accepting the lot for a given sampling plan. By varying the assumed percentage of defective items in a lot, several different sampling plans can be evaluated, and the sampling plan selected such that both the producer's and consumer's risks are reasonably low. Measurement System Analysis, or MSA, is a formal, statistical study that determines whether your measurement systems, whether they be measuring devices or people, are capable of providing reliable data so that you can make the best possible data-driven decisions. The statistical study used for continuous data is called a gauge R&R study, and the tool used for discrete data is called an attribute agreement analysis. A MSA study allows you to measure the variation of the observed weight due to the scale. If the proportion of variation of the scale is low, then you can conclude that the observed variation in the weight is really due to weight change and not due to scale performance. If the proportion of the total variation due to the scale is high, then you won't really know whether your diet is working. Time to buy a new scale. During your MSA study, you will assess your observed measurement from a number of different perspectives. They are: 1. Stability. Stability refers to the capacity of the measurement system to produce the same values over time when measuring the same sample. 2. Repeatability. Repeatability is the variation between successive measurements of the same part, same characteristic, by the same person using the same gauge. 3. Reproducibility. Reproducibility is the difference in the average of the measurements made by different people using the same instrument when measuring the identical characteristic on the same part. 4. Accuracy. Accuracy is the difference between the true average and the observed average. 5. Precision. The precision of the measurement system is the degree to which repeated measurement under unchanged conditions show the same result. 6. Bias. Bias is the difference between observed average measurement to the true or reference value. 7. Linearity. Linearity is the difference in bias value over the normal operating range of the measuring instrument. The 7 basic tools of quality, also known as 7 QC tools, originated in Japan, when the country was undergoing major quality revolution, and had become a mandatory topic as part of Japanese's industrial training program. These tools, which comprised of simple graphical and statistical techniques, were helpful in solving critical quality-related issues. These tools were often referred as 7 basics tools of quality because these tools could be implemented by any person with very basic training in statistics, and were simple to apply to solve quality-related complex issues. Design of experiments. That is, DO is a systematic method to determine the relationship between factors affecting a process and the output of that process. In other words, it is used to find cause and effect relationships. This information is needed to manage process inputs in order to optimize the output. The plan, do, check, act, that is PDCA cycle, is a 4-step problem-solving iterative technique used to improve business processes. Originally developed by American physicist Walter A. Shewhart during the 1920s, the cycle draws its inspiration from the continuous evaluation of management practices and management's willingness to adopt and disregard unsupported ideas. Why analysis is a method of searching for and finding the root causes of the problem. The name of the method comes from the main question asked during the analysis. Why? Thanks to asking that question many times, it is possible to find real, often hidden causes of the problems. Dealing with real causes prevents the problem from happening again.